Hello, math group. Here's a quick set of solutions for the desmos activity that we would have done together in class this week. So, I was all ready for you. I did not prepare to be ill, but we shall try to make up for that. One of our goals for this unit is to be able to convert between temperature systems, between Fahrenheit and Celsius temperatures. So I gave you some to practice on here. First one is a temperature of 41 degrees Fahrenheit. And then I just make it 41 degrees Celsius. To make these work, I put some information in the box over here. If we start with 41 degrees Fahrenheit, we would probably grab the equation that starts with C equals because we want to find Celsius. And then I plug in the 41 where the Fahrenheit temperature is, do the part in parentheses first, multiply by 5/9, and get 5 degrees Celsius. For the other one, the 41 degrees Celsius, probably we'd want to grab the formula that starts with F equals so that we can find Fahrenheit, plug in the 41 degrees, but notice that it's just 9/5 times the Celsius temperature plus 32. So that multiplication needs to get done first. 9/5 times 41 plus another 32 should give us 105.8 degrees Fahrenheit. So I think those are the two solutions for those requests. And then there's the work. Dimensional analysis is a big deal in this unit. It's a very powerful problem-solving tool, and you'll be asked to demonstrate it, so you get a bit of experience with it here. This one, we start with 28 inches, and we'd like to convert it to centimeters, but whenever we start with a quantity, that's our initial fraction, 28 inches over 1. That first fraction tells us what a person started with, whether it's someone else that we're critiquing or ourselves when we're doing our own work. 28 inches over 1. We need to convert that to centimeters, and so we'd need to have inches cancel in the denominator of the second fraction. So when somebody asks you the second fraction will be, it's got to have inches in the bottom. So it has to be this one. It can't be the other one. Inches will cancel out in this case. And then for the final answer, I set this all up in here. So the inches are canceling out. We'll have 28 times 2.54 up top. You'd have 1 times 1, which is just 1 in the denominator, so that denominator isn't very interesting this time. But other times it will be. I think you'll get 71.12 centimeters for this when you're all done. Here's someone else's work. We can analyze it. We can tell by the first fraction that they started with 14 feet. The feet are going to cancel, the inches are going to cancel, the centimeters are going to cancel, and we'll be left with meters. So we're starting with feet and ending up with meters. This work converts 14 feet to the equivalent number of meters, is a true statement. The final answer will not be measured in centimeters. The centimeters would have canceled out. When we do the calculation, the number that comes out for us should be 4.2672. Remember, you'll do 14 times 12 times 2.54. Figure out what that is, and then you'll divide by 100 this time, because 1 times 1 times 1 times 100 is 100. And your final answer is measured in meters. So that's analyzing someone else's work. Dimensional analysis works in situations even when we're not familiar with the units themselves. So I gave you some made-up units, and we're going to finish this one together. We need to convert 19 dorcons to flimmers. So 19 dorcons over 1 comes first. In my fact pair, up here, I can convert dorcons to snaggles. So the dorcons, if they're going to cancel out, need to be in the denominator, and it reads 12 dorcons. Means the same thing as 7 snaggles someplace in some made-up universe. So our dorcons would cancel, our snaggles would be left hanging around. We need to get those snaggles to go away, so snaggles will need to be on the bottom, and that'll put the flimmers on the top. So 5 snaggles means the same thing as 8 flimmers. All right, when we do this, we'll get 19 times 7 times 8 up top. 1 times 12 times 5 down below is 60. That part I could do in my head. We'll have flimmers left over. And then we need to do 19 times 7 times 8 and divide that by 60. And I don't know what that is, so I'm digging for a calculator. One moment. It'd be nice if my calculator would pick up all of the things I type. All right. I think I get, I'm going to put it down here, down below. Is it showing? Oh no. Got my stuff back. That's good. There was a moment where I was worried. All right. 17.73, and this will be flimmers. I will scoot it over, I promise. I think we should get that. 17.73 flimmers for a final answer. All right, so one more time so you can see all of it. Here's the setup. The Dorkans are canceling, the Snaggles are canceling, and flimmers are left over. And that's what we needed to do. We needed to get to flimmers. To make it happen, we need to multiply all those numerators together and all those denominators. And then we need to do a final division. 19 times 7 times 8 by itself, I did not type in there, but that would be 1064, and then you'd have to divide that by 60. Shoo. All right. There are lots of answers here that you could use. If we had been together, we would have done some puzzling with this, but for right now, you can just fill in your favorite rectangle. Explaining area and perimeter, you can go ahead and pause things here. There's another definition for perimeter and another definition for area, along with some examples of the units. This screen, this is true. Area is 2D space taken up by something or the number of squares covering a figure, and the perimeter is the path or the distance around any plane figure. I would accept that as true. This one, Bob has 480 square meters of space, and I would like you to tell me about some sizes of his garden that would meet those requirements. Because this is square meters of space, we're talking about area. And so each pair that you write down, each length and width pair, when you multiply those together, we need to get 480. That should give us 480 square meters. So just as one example, if we use 10 meters by 48 meters, that would give us 480 square meters. When you check your work here, multiply your length and width together, and you should get 480 every time. Bob makes a return here, and it seems like it might be the same problem. The number is the same, but this is meters of fencing, so it's really about our perimeter. So I make a note of that down here. 480 meters of fence, that's our perimeter. This means that whatever we write down for a length-width pair needs to give us a perimeter of 480. And I give you one example, 150 meters for a length and 90 meters for a width will give us 480 for our perimeter, since 2 sets of 150 plus 2 sets of 90 will give us, I have a typo, this should be 480. So check your perimeters here. Twice your length plus twice your width should equal 480 on this screen. It's the difference between area and perimeter from the first bob to the second bob. Oh, I love these. True-false statements stick around, kind of like from Unit 2. Sometimes you might hear something like this. There are 12 inches in a foot, so there are 12 square inches in 1 square foot. And while that has lovely symmetry when we speak, it is a false statement. This top one is true. 1 foot times 1 foot is 1 square foot. But 1 foot is 12 inches. And then the other one that we're measuring by is also 12 inches. So we get 144 square inches. And if you want to have a quick drawing over here of this, ooh, this is terrible. Don't look at this. Sheesh. If we have 12 inches over here, I'm trying to make it 2 little hash marks. 12 inches over here. I'm hoping you would agree this is 1 foot by 1 foot also. And then 12 by 12 is 144 square inches. Sometimes I draw the grid out. That's not going to happen today. Complete these statements. There are 3 feet in a yard, so there are, we don't know how many square feet in 1 square yard, but we can do it down here. 1 yard by 1 yard is 1 square yard. A yard is 3 feet, so 3 feet times another 3 feet for the second dimension is 9 square feet in 1 yard. For the other one, 1 centimeter by 1 centimeter makes a square centimeter. And then 1 centimeter is the same thing as 10 millimeters. 10 millimeters times 10 millimeters is 100 square millimeters. Those make good true-false questions also. Maya and the square. I do not think that Maya is correct. I think she actually found the perimeter. She counted up the stick lengths along the edges to get 12. Her perimeter would be 12 inches. The area would be 9 square inches. She could come along and just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. And she would have 9 square inches for that. Dante wants to tile his rectangular bathroom. Tile is going to cover the entire floor. And we also get a hint that we're talking about a covering or an area by the square feet language here. So I think for this rectangle, we need to do 8 times 12 for 96 square feet of tile needed. An addition to this problem would be something like, if we know the tile costs $3.54 per square foot, what's the bill for the tile going to be? Here's Jocelyn. She has a rectangular garden. It is 8 feet by 12 feet. She's actually looking for perimeter, so we can add all the way around her rectangle. She needs 40 feet of fencing for her garden in this case. So notice that Dante and Jocelyn have similar things going on with the 8 by 12, but one of them was asking for area and the other one was asking for perimeter. And that's what this screen is about. How are they similar? How are they different? They both had the same size rectangle, but one was working with area and the other was working with perimeter. So just because we have a rectangle doesn't mean we can just jump in and use area if that's our favorite. We have to be really careful and read and see what it's asking for. Sketch tool. I'd like a rectangle that has an area of 30 and a perimeter of 22. And I think this is best done by guess and check. And I would start with the area if I were you. So if we had a rectangle that measured 10 by 3, we'd have 30 square units. 15 by 2 also gives us 30 square units. So does 5 by 6, and there are others. But I also want a perimeter of 22. So if this is my area, and I come over here, then the perimeter would have to be 2 sets of 10 plus 2 sets of 3. So that's going to be, 26 would be our perimeter there. And that would be plain units. So this one doesn't work. This is not the one we want. We want a perimeter of 22. This is pretty close though. 15 by 2, if we come along and we check its perimeter, we're going to have 2 sets of 15. And we'll have 2 sets of 2. And that'll give me 30 plus 4, which is 34 units for the perimeter. I kind of think this is the one that's going to work. If we had a 5 by 6 rectangle, we'd have 2 sets of 5 plus 2 sets of 6. That would give us 10 plus 12, which is 22 units. And that is the one that we want. Exclamation points there. And if you want to draw it in, because it said to, we'd have to have 1, 2, 3, 4, 5, 6. So it's got to be 6 tall and then 5 wide. 1, 2, 3, 4, 5. Did I count that right? 1, 2, 3. Yep. It's got to be like this. So it's 6 one direction, and I don't care which direction is which, but 6 by 5 will give us that area of 30, and then if we added up our perimeter, we'd get that 22 that we want. So a little bit of puzzling sticks around in this unit, and this is like a guess and check table, kind of like we saw in the last unit. It's like that. All right, Marco says, oh, the numbers for the area and the perimeter will always have to be different. There is a counter example to this, and I think there's only one that exists. this is supposed to be 4 units one direction and 4 units the other direction. And I believe if you find the area, you'll use 4 times 4, which will be 16 square units. And when you find the perimeter, it will be 4 plus 4 plus 4 plus 4, which is also 16 units. The numerical portions match, 16 for the area and 16 for the perimeter, but the labels do not. One is square units and one is square. But it does, or one is square units and one is plane. It does provide a counterexample to Marco's statement though. Lots of questions we could ask about Juan and the patio. Okay, this was a what questions could we ask? What answers could we provide? I listed a few. You might have some others. How many square feet of patio blocks are needed? What's the cost going to be? How much edging will we need? What's that going to cost? And we could solve all of those. Those are all very valid for our course. Switching things up to circles, I give you the formula for the circumference of a circle and also for the area. So I put that in the notes here. We do need to know about the radius to use these equations, so it will probably help to know that the radius of a circle goes from the center out to one edge, and it's half of the diameter of the circle. Here's Juan in a circular patio. He's got a patio, or he wants to make one that has a 12-foot diameter. We're wondering how many square feet of patio blocks will he need, and how much edging will he need. So I make a note here. We have the diameter. We're going to need the radius. The 12-foot diameter corresponds to a 6-foot radius. Radius is half the diameter. For our patio blocks, we're talking area. So there's the formula for the area of a circle. We just declared that our radius was 6, so it gets filled in. The 6 should be squared before you do anything else, if you're doing this piece at a time. And then we'd have pi times 36 for about 113 square feet. I rounded it to the nearest thousandth. For the edging, that would be perimeter. That would be a different formula. C equals 2 pi r. The radius is 6 again. And when you do this computation, I think you'll get 37.699 feet, rounded to the nearest thousandth. If we knew the cost of things, we could also incorporate that, but I don't think that we knew that in this problem. And then I think that is about all of the info that you need for this one. If you have specific questions on your work or questions on something that you saw in here, please let me know.